So in the review, you have total 52 questions, but in the final, you will have total 49 questions. So the based on a random sample of 1,000 people, a researcher obtained the following estimates of the percentage of people lacking health insurance in one US city. So we have the age limit and percentage not covered. So we need to classify the study as either descriptive or inferential statistics. So what do you think? Is it descriptive statistics or inferential? Okay, so you're asking when is the review due? So it is due day before the final. So your final will be on December 7th. So it is due on December 6th. Okay, so you are saying inferential. Okay, so inferential statistics means based on the statistic, we'll make inference about the parameters, or based on the sample, we'll make inference about the population. Okay, so let me check. You're saying it's inferential, but yeah. So we have here 10,000 sample of 10,000 people, right? And a researcher obtained the following estimates of the percentage of people in one US city. And based on this, we are making inference. So this is inferential statistics. Yeah, but the first question is a little bit confusing to me, because based on a random sample of 1,000 people, a researcher obtained the following estimate of the percentage of people lacking health insurance in one US city. Okay, so yeah, the researcher obtains the estimate and they're making inference about the lacking health insurance in one US city, and they are making this insurance based on the sample, based on sample of 1,000 people. So that's why this is inferential statistics, not descriptive. Okay, so 30 of 198 students enrolled in statistics 101 were asked if they wanted exam 2 to be a take-home or an in-class assessment. 20 or about 67% of the students polled indicated a preference for an in-class exam. The professor concluded that the majority of students in statistics 101 would prefer an in-class examination for exam 2. Did the professor perform a descriptive or inferential statistics? So what do you think? Is it descriptive or inferential? The professor is making inference, right? So I think it should be inferential statistics. Yeah, classify the data as either discrete or continuous. So what type of data is provided by the statement, Helen finished in 5th place in the ice dancing competition? So what do you think? Is it discrete or continuous? Yeah, this is discrete, right? Because 5th place, so it should be discrete number, discrete values. So this is, yeah, that's correct. Okay, so construct the requested graph. So we need to construct the bar graph for the relative frequency. So we are given the relative frequency table and relative frequency table. So we need to construct the bar graph because this is qualitative data, right? Our first variable is qualitative. So we don't see ever. So here we have the names and we have the frequency and we have the relative frequency. So now we need to construct the bar graph. So for the first one, the relative frequency is 0.10. This is 0.10, then 0.05, then 0.45. Yeah, this is also correct. Then 0.05, that's correct, 0.05. Then this is 0.30. Yeah, the height of this bar is also 0.30. And the height of this bar is also 0.05. Yeah, I think the first one is correct. Okay, so let's check the other three. So how about the second one? It seems correct. This one is okay. This one is not correct, right? It should be 0.45. And for this one, yeah, first one is okay. Second one is not correct. It should be 0.05. So that's mean the answer should be the first one. Yeah. So given the following data scenario, decide which type of grouping is probably the best. So you need to select the type of grouping. So we learned three type of grouping, right? Single valued, limit grouping, or cut point grouping. So when we have discrete data, in that case, you can use either single value or limit grouping. So if you have only the number of observation is finite, means like if you have a small number of observations, then in that case you can use single value grouping. But if you have the number of observation is large, in that case, for the discrete case, you can use limit grouping. But for continuous case, we always use cut point grouping. So now you need to determine actually here whether the data is continuous or discrete. So here our variable is the wingspan length and to the nearest hundredth. So this is continuous data, right? So for continuous data, we use cut point grouping. So that's mean the answer should be here cut point grouping. Yeah, this is cut point grouping. Okay, our teacher asked is of her students how many novels they have read in the previous 6 months. The results are shown in the right. So we have the data, right? So now we need to construct the frequency table. So for frequency table, so since this is discrete, so either you can use limit grouping or you can use single valued grouping. So here we have actually, this is mixed. This is kind of mixed. So we are not going to use this type of grouping. So either we'll use single value grouping or limit grouping. So here it is given that we used single value grouping. So part D is not, so option D is not correct, right? It's incorrect, this one. Okay, so now look at the first one. So you do not need to check actually for all the numbers. You can check for the first one, from the first three. So we'll have the correct answer in the first three, right? Either A or B or C. So look at 0. So we have 7, 7, and 11. So actually you will be using method of elimination. So you will eliminate one by one. So for 0, how many observations we have here? We have 7 observations. So that's mean we can eliminate part C, option C. So now we have option A and B. So this is 7, and this one has 10, this one has 11. So we can check for this one. So how many ones we have actually? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can eliminate this one now. So that's mean the correct answer is part B. So this is the correct answer. So if you do this way, then it will save your time. You do not need to check for all the numbers. Okay, a graphical display of the data set is given. Now we need to determine the shape of the distribution, whether the shape of this distribution is uniform, left skewed, Z-shaped, and triangular. So what do you think? Which one should be the correct? in this case. Okay, so if you have this type of distribution, then this is called symmetric or bell-shaped. So if you have this type of distribution, then this is called uniform. This is uniform. And if you have this is left skewed. And if you have this type of distribution, this is right skewed. And this is called, sorry, this is called reverse Z-shaped. And triangular is kind of this, if the shape of the distribution like this. So what do you think? Is it uniform, left skewed, Z-shaped, or triangular? Anyone? Yeah, this is uniform, right? Because it looks like this, the shape of the distribution looks like this. So that's mean this is uniform distribution. Yeah, that's correct. Okay, 6 college students spend this amounts respectively for books. Compute the mean amount spent. So you need to calculate the mean. So that's mean you have to calculate the average. So you need to add them together, all the numbers. So first number is 198.94 plus 135.65 plus 174.92 plus 221.91 plus 120.78 plus 141.31. And how many numbers we do have? 2, 4, 6. We have 6 numbers. So divided by 6. So it is 165.59. So the mean is 165.59. So this is the correct answer. Okay, so in the final, actually, when you have 4 options, that's mean you have 2 chances to select the correct answer. So if you select this one, this is incorrect answer. So that's incorrect. Now let me select this one. Yeah, so that's when you will have 2 chances to select the correct answer when you have 4 options. Okay, the next one is find the median of the given sample. So you have to find the median value. So how many numbers we do have here? 10, right? So in the median we have actually 2 values in the middle, 6005 and 1029. But first you need to check whether they are in either in increasing order or decreasing order. So they are not in order, right? So they are not ordered data. So first you need to rearrange them. So smallest to largest. The smallest number is 1029. Then next number is, I think, 2565. 2565. Then 2919. Then I think 3510. Then next number is 4174. Then 6005. Yeah. Oh no, 5420. Then 6005. Then we have 7003. Then 7122. Then 8514. Yeah. So we rearranged them or reordered them in increasing order. So now we have 2 middle values, right? So these 2 numbers are in the middle. So that's when the median will be average of these 2 numbers. So you will add these 2 numbers, 4174 plus 5420 divided by 2. So this is 4797. So the median is 4797. Yeah, do not forget to rearrange them in order when you will be finding the median. Okay, so this is 4797. Okay, find the sample standard deviation of the given data. So you need to find the sample standard deviation. So you can use calculator or Excel sheet. So I'll recommend you to use Excel to calculate the standard deviation, to calculate the mean, and to also to find the critical value. For everything, you can use the Excel. So if you use Excel sheet, then you can easily find the mean, standard deviation, variance, and also the other measures. Or you can also use calculator. So whatever you prefer. Okay, so now we have to find the standard deviation. So I'm not going to calculate this. Let me check which one is correct. No, this is not correct. Okay, the correct answer is 4.8. Okay, so you can use either calculator or you can also use the formula for the standard deviation. The sample standard deviation, the formula is S is equal a square root of summation of xi minus x bar square divided by n minus 1. So here n is 2, 4, 6, 8. N is 8. And you need to find the x bar. Then you will subtract x bar from each number and square them, then add them together, divide by n minus 1, divide by 7, then take the square root. So you do not need to actually show the steps. So that's mean you do not need to actually use this formula. So you can directly use the calculator or Excel sheet. Okay, so here we need to find the sample standard deviation. So you can use the calculator to find the sample standard deviation. And this is 13.34. Okay, so the age of the members of gym have a mean of 48 years. So the mean value is 48 years. The X bar is 48 years here. Okay, and standard deviation is 10 years. So X bar is 48 and standard deviation. Okay, so actually this is mu and sigma is 10 years. What you can conclude from the Chebyshev's theorem about the percentage of gym members aged between the, so we need to find the percentage between 25 and 71, and you have to use the Chebyshev's theorem. So now you need to determine how many standard deviation away from the mean is 25 and 71. The mean is 48. So we need to subtract 48 from 25. So this is actually 25 minus 48 divided by 10. So if you divide by standard deviation sigma, then it is negative 2.3. And similarly, if you subtract 48 from 71 and divide by 10, it will be 2.3. So that's mean these values are within 2.3 standard deviation from the mean. So the value of k is 2.3. So that Chebyshev's theorem said that 1 minus 1 over k square times 100% of the observations will be between, at least this percent of observations will be between these two numbers, 25 and 71. So that's mean 1 minus 1 over 2.3 square times 100%. So this is 1 minus 1 over 2.3 square times 100%. So this is 81.10. So that's mean this is 81.1%. Okay, so now we have actually two options where we have 81.1%. So which one should be correct? So what do you think? B or C? So we found 81.1%. So it is at least or at most. So which one should be correct? So what does the theorem, Chebyshev's theorem say? Anyone? Yeah, part option B is correct because the theorem said at least that percent of observations will be between 25 and 71. Yeah, that's correct. Thank you. So that's mean the correct answer is B. Yeah, the correct answer is B. Yeah, be careful when you'll be answering this one. The percent is at least 81.1%. Yeah, but the good thing is you have two chances. So yeah, anyway, you'll get the correct answer. The test scores of 19 students are listed below. So we have the test scores of 19 students. We need to find the quartile. So we have to find the third quartile, Q3. So how do we find Q3? First, we need to find Q2. Q2 means the median. So the median is the middle value. So how many observations do you have here? We have 15 plus 4, 19 observations. So the middle, we will have just one value in the middle. And so total we have 19. So the middle value will be 19 plus 1 divided by 2. So the 10th observations will be the middle value. So that's mean the 10th observation is 65. So 65 is the median. So now we need to calculate Q3. So how do I calculate Q3? Since 65 is in the data, so we need to divide the data set into two subsets. And in each subset will include 65. So 36 to 65 is one subset. And the other subset will be 65 to 98. And Q3 is the median of the upper half of the data. So that's means 65 to 98. We have to find the median from 65 to 98. So 65 to 98, we have total 10 observations. So that's mean we'll have two values in the middle. And the two values are 81 and 84. So we need to take the average of these two numbers. 81 plus 84 divided by 2. So this is 82.5. So that's mean the Q3 is 82.5. Okay, so here we have to construct the box plot. So for box plot, you need 5 numbers. Summary, you need the minimum, the mean, the max, and this is Q1, Q2, Q3. So you need this information to construct the box plot. Okay, so here we have total 2, 4, 6, 8, 24 observations. So we have total 24 numbers here. So that's mean the minimum is 310 and maximum is 3700. And for all the options, we have the correct answer, right? 310 and 3700. Yeah. Okay, so that's when we couldn't eliminate anyone yet. So now look at so for this one, we have, for Q1, we have 500. And for Q1, we have, okay, so how about Q2? So Q2, we have 705, 700, 705, and 700 here. Okay, so first find the median. The median will be the middle. We have total 24 observations. So that's mean the median will be the average of the 12th and 13th plus of the data. So that's mean this is 8, 9, 10, 11, 12. So the median is the average of these two. We have two values in the middle. So the average of 700 and 710 is 705, right? 705. So that's mean our median will be 705. So we have here 705 and here 705. So we can eliminate this one and eliminate this one. Okay, so now Q1, we have 510 here, 510 here. That's also correct. We have 1225 and 1225. That's also correct. Now, you will look at the difference. So here, this is 310, this is 510, and this is 705. So this from here to here, the difference is 400 something. And from here to here, the difference should be 700 and 1200, so 520. But if you compare this one, this is 400 something and this is 500. So I think this is not consistent. So how about this one? Okay, so this is 310 and this is 510. So the difference is 200 and this difference is 510 and 7 less than 200. So here to here, this is 200, and here to here, this is almost 200. I think this is not correct because it's not consistent, right? Because this distance is way more than this distance, but they are representing 200 from the data. But yeah, so I think the correct answer should be this one. Let me check. Yeah, that's correct. Do you have any question? Okay, so here we need to find the probability. So a bag contains 4 chips of different colors, including red, blue, green, and yellow. A chip is selected at random from the bag and then replaced in the bag. So a chip is selected random and it is replaced again. Then a second chip is selected at random. So make a list of all possible outcomes. For example, so we have 4 different colors of chips. We have red, blue, green, and yellow. So first we'll select one randomly, any one of them. So we can select either R, we can select either this one or this one or this one, right? So for this one, how many options do we have for the second one? So we can select, since we replaced it again, so that's when we have again 4 chips, and we can select either R, we can select B, or this one. So for each one, we'll have 4 outcomes, right? And similarly for this one, we'll have 4 outcomes. And similarly for this one, we'll have 4 outcomes. We can select R, B, green, yellow. We can select red, blue, green, yellow, and similar to this one. So that's mean total number of observations is 16. So total number of observation is 16, right? So now we need to find the probability that 1 blue and 1 yellow chips are selected. So how many observations, how many favorable observations we have? That's mean how many observations we have in our favor. So either we'll have red, blue, or blue, red. So in the first one, we have just one choice, right? Red and blue. How about this one? We have just one choice here, but we do not have any choice here. RB, right? Red, blue, or blue, red. We do not have any choice here. So we have 1 observations here, 1 here, 0 here, 0 here. So how many favorable observations we have? 2. So the probability will be then 2 over 16. So this is 1 over 8. So that's mean the probability will be 1/8. But if you are asked that first one is red, second one is blue, so that's mean in that case we have just one option, right? We have just in our favor. So in that case, the probability would be 1/16. But here we can have either red, blue or blue, red. So that's mean we have two choices. So that's why the probability is 2/16, which is 1/8. So the correct answer is 1/8 in this case. Yeah, this is 1/8. Okay, so when a quarter is tossed 4 times, 16 outcomes are possible, right? So if we toss a quarter 4 times, then we can have 16 outcomes, 16 possible outcomes. Okay, A is the event that the first 3 tosses come up the same. So A is the outcome that first 3 tosses are same. So that's mean in the first 3, either we can have H, 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 or we can have T, T, T. Okay, so T, T is represents the outcome that the first toss is heads and the next 2 tosses are tails and fourth tosses is heads. This is the, so A, the first 3 tosses come up the same. So that's mean, and here we can have either head or we can have tail. And similarly, we can have here head or we can have tail, 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 and tail. So that's mean these are the possible outcomes. So the correct answer should be this one, the last one. So the correct answer is part D. Okay, so 3 board members for a non-profit organization will be selected from a group of 5 people. So there are a group of 5 people, and we have Allison, Bertie, and Charlie, C, Dave, D, and Emily, E. So we have these 5 people, A, B, C, D, E. And the possible outcomes can be represented as follows. So these are the possible outcomes. So that's when we'll select 3 of them from 5. So that's when we can have ABC, we can have ABD, we can have ABE, and so on. So these are the possible outcomes. So A is the event that Mary and Emily are selected. So that's mean A is the possible outcomes that B and E are selected. So how many outcomes do we have? B and E. This is not B and E. Here we don't have. So we have here and this one and this one. So we have 3 outcomes, right? A, B, E, B, C, E, and B, D, E, where we have these 2 persons, right? So that's mean the correct answer will be the event A will be then this one, option B. Yeah, the correct answer will be then this one. Okay, the number of hours needed by 6th grade students to complete a research project was recorded with the following results. So this is the number of hours and this is the number of students. So in 4 hours, 18 students completed the research project, and in 5 hours, 22 students completed the research project, and so on. A student is selected random, and the events A and B are defined as follows. So A is the event that the student took between 6 to 9 hours inclusive. So the students who took 6 hours or to 9 hours. And B is the event that the student took at most 7 hours, maximum 7 hours. So that's mean for event B, the number of students should be here to here, at most 7 hours, so maximum 7 hours. And for A, so this is our B, and for A, 6 to 9, and 6 9 are inclusive, so that's mean 6 to 9 here to here, so that's mean here to here. This is our A. So now we need to write the determine the number of outcomes that comprise the event A or B. A or B, either A or B. So that's been here to here, right? Sorry, here. So we need to add them together. So we have how many students we do have here? We have total 18 plus 22. So that's been 40 plus 6. This is 16, or let me clear the drawing. So that's when we have to add here to, okay, sorry. 40 plus 16, 56 plus 9, 56 plus 9 is 75, plus 14 is 89, plus 7 is 89 plus 7 is 96, I think. Okay, but we do not have 96, we have 86. Okay, so let me count it again. I think I did mistake. This is 40 plus 16 is 50. Okay, so yeah, we did actually mistake. So 18 plus 22 plus 16 plus 9 plus 14 plus 7. Okay, so here the problem is we counted some student twice, right? Because you can see here, so even A, the student who took between 6 to 9, 6 to 9 is here to here. And at most 7 means here to here. So these students, they are counted twice, 16 and 9, right? Because when we counted the students took at most 7 hours, we counted those students who took 6 hours and 7 hours. And when we counted for B, sorry, for event A, we also counted the students who took 6 hours and 7 hours. So that's why we need to subtract 16 and 19 once, because we counted them twice. Then it will be total 96 minus no, so let me do it again. So 18 plus, let me use the calculator. Okay, so 18 plus 22 plus 16 plus 9 plus 14 plus 7 minus 16 minus yeah, it is. Actually, I told you wrong. So we didn't actually count twice because we are just counting once, because we didn't consider it twice. Yeah. So this is actually 86. Okay, so because we didn't count it separately. So if you count it separately, like if you count the number of students for A and number of students for B and add them together, yeah, in that case, we are counting 16 and 19 twice. But since we are just counting from here to here, so that's mean we are just counting once. Yeah, actually I told you wrong. Yeah, we didn't count it separately. So that's mean we didn't count it twice. Okay, so it should be actually 86. So the answer is 86. Okay, a bag contains 2 red marbles, 3 blue marbles, and 7 green. So if a marble is randomly selected from the bag, what is the probability that it is blue? So we have total how many marbles we do have? We have 2, 3 plus 2 plus 7. So 2 plus 3 plus 7 is 12. So how many ways we can select one single marble? We can select in 12 ways. And how many ways we can select a blue marble? Since we have 3, so we can select a blue marble in 3 ways. So that means it will be 3 over 12. The probability will be then 1 over 4. So the probability in this case is 1 over 4. So the probability is 1 over 4. Okay, so find the indicated probability by using general addition rule. For a person selected randomly from a certain population, events A and B are defined as follows. So A is the event, the person is male, and B is the event, the person is a smoker. So for this particular population, it is found that, so we are given that the probability of A is 0.52 and probability of B is 0.33 and probability of A intersection B, or you can say probability of A and B, they are same. This is equal 0.146. So we need to find probability of A or B. So this is equal probability of A plus probability of B minus probability of A intersection B. So that's mean you need to add 0.52 and 0.33. So 0.52 plus 0.33 minus 0.146. So this is 0.704. So in this case, the answer is 0.704. So this is the probability. Do you have any question? Okay, thank you. Actually, in the final, most of the questions are very basic questions. So, and I think they're very simple questions, not very hard. Yeah, so I think you should be fine if you just go over the review problems. Because for solving these problems, it is not taking that much time, and it is just kind of conceptual questions. So not that much calculation. Yeah. And most of the questions are multiple choice questions. So suppose that two balanced dice, a red die and green die, are rolled. And Y denote the value of green and green minus red. Okay. Where Z represents the number on the green die and R represents the number on the red die. So what are the possible values for the random variable Y? Okay, so for the green die, we can have number 1, 2, 3, 4, 5, 6, right? And for the red one, we can have also 1, 2, 3, 4, 5, 6. So green minus red. So the possible values are, so if we do 1 minus 1, so this is 0. 1 minus 3 is minus 2. Sorry, 1 minus 2 is minus 1. 1 minus 3 is minus 2. So 1 minus 4 is minus 3. 1 minus 5 is minus 4. 1 minus 6 is minus 6. And similarly, 2 minus 1 is 1. Then we can have 2 minus 2, 0, minus 1. And oh, this is minus 5 actually. Yeah, not minus 6. This is minus 5. Yeah. And so on. So the maximum number we can have 6 minus 1, right? 6 minus 1 will be the maximum number for green minus red, right? 6 minus 1, which is 5. And the minimum number is 1 minus 6, which is negative 5. So the minimum is negative 5 and maximum is 5. So the possible values will be minus 5 to 5. So which one is correct then? In A, we have minus 6 to 6. So this is not correct. So in B, we have minus 5 to 5. Yeah, this one is the correct answer. Minus 5 to 5. Okay, the following table displays a frequency distribution for the number of living grandparents for students at a high school. And for a randomly selected student in the school, let X denote the number of living grandparents of the students. So X is the number of living grandparents of the students. Obtain the probability distribution of X. So how many living grandparents could be possible? Maximum 4, right? And minimum is 0. So the possible values are 0 to 4, 0, 1, 2, 3, 4. And we have the frequency corresponding to each number. So now we need to find the probability corresponding to each number. So for 0, the probability will be then, okay, so you need to find the total number of students. Total is 38 plus 72 plus 154 plus 220 plus 152. So the total is 636. So the total is 636. So corresponding to 0, for 0, the probability will be then 38 over 636. So which is 38 over 636, which is 0.075. Okay, so we do not have any 0.075. Okay, so let me, oh, I did actually 48 over, so it should be 38 over 636. So this is 0.597. So that's means 0.06. Yeah, so this is not correct. This is not correct. This is not correct. So the correct answer is the first one. Yeah, the correct answer is the first one. Okay, so here the random variable X is the number that shows up when a loaded die is rolled. Its probability distribution is given in the table. And find the mean of the random variable. So we have to find the mean of the random variable and round to 2 decimal places. So we have to find the mu. Mu is the expected value of X, and which is the summation of X times probability of X is equal X. So that's mean we have to multiply the value of X and the corresponding value of P, probability of X equals to X, and add them together. So multiply this one to this, 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 and this one to this, and add them together. So that's mean 1 times 0.11 plus 2 times 0.15 plus 3 times 0.13 plus 4 times 0.12 plus 5 times 0.13 plus 6 times 0.36, and then you need to add them together. So if you add them together, then it will be 0.11 plus 0.3 plus 0.48 plus 0.65 plus 6 times 0.36. So it is 4.09. So the expected value is 4.09. So you will get 4.09. So the correct answer will be then this one. Okay, so let me clear all the drawings. So this is the correct answer.